Welcome to Daily AI Brief, where we dive into the latest advancements in artificial intelligence. Today, we're exploring three cutting edge topics: newly enhanced AI models through quantization-aware distillation, revolutionary changes in recommendation systems with generative recommenders, and NVIDIA's real time AI development platform, Holoscan. Let's get started. AI enthusiasts, gather around as we unpack a significant leap in AI model efficiency through quantization-aware distillation, CAD. This method is dramatically enhancing the performance of several AI models, notably the ACE Reason Nemotron, Nemotron Variations, and the Llama Nemotron Super V1. Here's the scoop. Quantization-aware distillation is a technique designed to transition AI models from high-precision formats to more compact, efficient forms without losing significant accuracy. NVIDIA's innovation in this area, particularly the NVFP4 format, is a game-changer, significantly boosting inference operations. Let's look at how it works. Quat takes a high-precision teacher model and distills it into a quantized student model using KL divergence loss to maintain accuracy. This process incorporates post-training quantization, minimizing the need for complex task-specific loss functions. Moreover, its integration with NVIDIA's NVFP4 improves both throughput and memory efficiency, allowing these models to run smoothly on resource-constrained edge hardware. On the numbers front, QAD achieves a four-fold increase in floating point operations per second, FLOPS, over the BF16 format and 1.7 times the memory savings compared to FP8. Benchmarks show these models maintain performance close to BF16 accuracy, even at lower precisions. The ACE Reason Nemotron and others have demonstrated enhanced throughput, crucial for real-time processing applications. Through such advancements, deploying high-performance AI models on edge hardware becomes increasingly feasible, promising improved efficiency and more sophisticated capabilities. However, not everything about QAD is perfect. The long-term stability of these methods across various models and tasks hasn't been fully validated. There's still uncertainty about how these models will perform in smaller architectures or different environmental conditions. For those curious to dive into this technology, you can start by cloning the NVFP4 repository and experimenting with quad implementations. Enhancements can also be seen by upgrading LFM 2.5 models, as discussed in the official documentation available on platforms like Hugging Face. Ultimately, quantization-aware distillation represents a critical advancement for deploying efficient AI models on edge devices, opening doors for more real-time applications without compromising on performance. Let's shift gears and delve into generative recommenders, led by the Hierarchical Sequential Transduction Unit, HSTU, which are reshaping how we think about recommendation systems. Understanding the mechanics. Unlike traditional deep learning recommendation models, DLMs, that struggle with scalability and efficiency, these new generative models bring both aspects into the spotlight. The ability to manage high cardinality and non-stationary data streams provides a competitive edge. Hashtag components of HSTU, generative modeling. By reformulating recommendation tasks, HSTU effectively handles both retrieval and ranking processes, combining them into a single, seamless activity. Advanced attention mechanisms. While previously bottleneck points, these mechanisms are now designed to significantly enhance overall performance. Integrative frameworks. HPGR, Hierarchical Prior Generative Recommender, incorporates structural priors to add layers of depth, enabling more accurate and dynamic recommendation strategies. Context parallelism supports jagged tensor structures, improving efficiency and allowing a 5.3x increase in user interaction sequence lengths. Performance and potential. With 1.5 trillion parameters, these models have shown a significant 12.4% improvement in recommendation metrics. This quantitative uplift was highlighted in online A/B tests, demonstrating the value and potential of HSTU in real-world applications. Implementation insights. For developers and engineers interested in integrating these cutting-edge systems, NVIDIA provides comprehensive resources. NVIDIA HSTU documentation, docs.nvidia.com/deeplearning/Triton inference server/users docs tutorials/popular models guide/HSTU/readme.ana/OpenAI. offers detailed implementation guidelines. Git perf Git NVIDIA Rex examples slash blob examples HSTU readmd udemsor OpenAI. Contains example implementations to facilitate experimentation and deployment. Furthermore, exploring recent page exep arxiv.org 2603.00980 Thorsyth. And context parallelism Tarksutify 8.04711I can provide deeper insights in these emerging technologies. Considerations and challenges. Despite these advancements, attention mechanisms still present performance bottlenecks, which might restrict scalability efforts. Moreover, significant computational resources necessary for large-scale deployment could be prohibitive for smaller entities. The future of recommendation systems. Generative recommenders mark a pivotal advancement over traditional models, positioned to revolutionize high-demand, data-rich environments. As these systems continue to evolve, they may set new industry standards and influence future machine learning frameworks, emphasizing real-time data processing and enhanced personalization. In conclusion, although some challenges remain, the promise of improved efficiency and accuracy makes generative recommenders an exciting frontier in the realm of recommendation systems. NVIDIA's Holoscan is setting a new benchmark in real-time AI application development, with transformative potential for industries like medical imaging and robotics. Launched as part of a strategic push to enhance AI capabilities, Holoscan stands out for its integration of high-performance components such as the NVIDIA Jetson AGX Orin, RTX A6000 GPU, and ConnectX-7 SmartNIC. These elements synergize to deliver up to 619 trillion operations per second, catering to sectors that demand rapid processing and low latency performance. One of the core strengths of Holoscan lies in its optimized libraries and core microservices, specifically tailored for accelerated data processing tasks and sophisticated AI computation. This suite of tools is complemented by its seamless integration with the NVIDIA IGX platform, which not only boosts performance, but also addresses critical security concerns, essential for industries bound by stringent regulatory standards. This ensures applications meet and maintain compliance with healthcare and industrial safety regulations, fortifying trust and reliability in the AI solutions deployed. The focus on edge computing is another strategic advantage. As organizations increasingly transition to edge-based systems for real-time data processing, Holoscan facilitates a streamlined development process that can quickly adapt to enterprise-grade software requisites. This adaptability is indispensable in environments where milliseconds can have profound implications, such as diagnostic imaging or real-time robotic movements. However, adopting Holoscan is not without challenges. Existing medical and robotic systems may face integration difficulties, potentially slowing down widespread implementation. Moreover, the market is becoming increasingly competitive, with multiple players developing similar technologies. NVIDIA must continuously innovate Holoscan to maintain its edge and distinguish itself in the landscape. For those interested in exploring Holoscan, NVIDIA's website offers extensive documentation, along with sample applications available on GitHub. Developers can leverage command line interface (CLI) resources to gain practical experience in setting up applications, providing a comprehensive understanding of how Holoscan can be utilized in real-world scenarios. By providing robust, adaptable, and high-performance AI development solutions, NVIDIA's Holoscan stands as a pivotal tool that could redefine standards across industries. Its ability to handle extensive operational demands while ensuring compliance and security positions it as an invaluable asset in the ongoing evolution of AI technology. That's a wrap for today's episode. From the nuanced advancements in quantization-aware distillation and generative recommenders to NVIDIA's trailblazing Holoscan platform, AI is advancing at an unprecedented pace. Stay informed, keep experimenting, and join us next time on Daily AI Brief as we continue to explore the forefront of technology.